Today's lesson is 1.2, segments and distance. The points on a number line can be matched one-to-one with real numbers. The real number that corresponds to a point is the coordinate of the point. When we talk about distance in geometry, it is the length between 2 points. My distance must always be positive. I cannot ask you to walk -2 blocks back to your house from El Paso High. I can't ask you to drive -250 miles to Albuquerque, New Mexico. That doesn't make sense. So we always have to think of our distance as positive, no matter where we are on a number line or our position in space. Let's go ahead and take a look at an example. We're going to find PQ, that's going to be the distance from P to Q, and QR, the distance from Q to R, on the number line below. So all we simply have to do on a number line is find the points. For the first one, we're going to go ahead and find P and Q. Here they are. And we simply have to count the distance between them. Be very careful when you count on a number line because it can be misleading. You might think it's 1, 2, 3, but it's actually each one is a half. So this is a half, 1, and a half. Because notice that from 0 to 1, there is a bar in between. This is half. So each one is a half. So half, 1, half. So my answer is going to be 1.5. Half, 1, half. Let's go ahead and do the distance from Q to R. So Q to R. And I'm simply going to count. I'm going to use the bottom this time. Half, 1, half, 2, half, 3, half, 4, half, 4, and 1 half. And then, of course, we could go ahead and put some distance on it. If B is between A and C, then A, B, and C are collinear. So when you see this statement, if B is between A and C, then A and B are collinear. What this means is I can just write this first sentence. I can change that comma to a period, and I'm letting you know what the picture looks out like without actually drawing it for you. So I'm showing you that there's this line, segment. One point is A, one point is C, and somewhere in between there's B. So one is A, the other is C, and somewhere in between is B. I do not technically have to draw this for you, but for this first part of geometry, I'm going to go ahead and do so until we get familiar with what our pictures should look like. All right, so let's go ahead and take this idea of distance and let's move it to a segment. So if B is between A and C, we're going to find the distance from A to C if AB is 4 and from B to C is 5. Let's go ahead and draw that picture. So that first part tells me I have a point, I have a line segment, at the other end I have another point, and somewhere, and these two are A and B, A and C, and somewhere in between, it doesn't have to be the middle, but if you want it to be the middle, it can be. Between does not mean the middle in geometry. Between just means it's somewhere in between them. Some maybe it's closer to A sometimes, maybe closer to C, maybe sometimes it is the middle. All right, then it says right here that AB is 4, so I'm going to go ahead and put a 4 right here, which means from this letter to this letter it's 4, and then it says right here from B to C is 5, so I'm going to go ahead and put a 5 right here, which means from this letter to this letter is 5, and it asked me to find, let me grab another color, it asked me to find AC. How long is that? Well, if you take a look at it with the color, to get that pink across the top, I need the blue and I need the purple. So all I have to do is add 4 plus 5, and my length is 9. That's it. All right, let's go ahead and take that idea and let's make it into a, oh no, we're going to try it one more time. Sorry, we're going to try it one more time. Okay, K is between J and M. L is between K and M. M is between K and N. All right, ooh, this one's going to be tough. Let's draw our segment. Let's put our points. K is between J and M. L is between K and M. M is between K and N. Okay, so here's what we're going to do. I'm going to start with the first part. K is between J and M. So I'm going to say J, M, K. L is between K and M. So I'm going to put L right here. And M is between K and N. So it's got to be right like that. So I'm going to have J here, and this has got to be N. Somewhere here is K, somewhere here is L, and somewhere here is M. That looks a little better. All right, let me go ahead and erase this. There we go. And let's start putting in the numbers. So from J to N, from J to N is 14. From K to M, it is 4. Okay. From JK is the same as KL, is the same as LM. And we're going to have to go ahead and find this. So when I have something like this, these are what are called congruent segments. These are segments that are equal in length. So let me write that down. That are equal. And when we mark them, if you notice what I did with my purple is I marked them with a little tick mark. So to show a picture that they are exactly the same length, all I did was I marked them with a little like tick mark, a little hash mark. Um, what I can then say is since I know from here to here is 4, and each of these pieces have to be the same, all I have to do is divide 4 by 2, and each of those pieces has to be 2. Okay, so this has to be 2, this has to be 2, which means this is 2. Okay, which means now I know that from J all the way to M, it's going to be 2 plus 2 plus 2, which is going to be 6. So to find this last piece that I need, all I need to do is take the 14, which is the whole piece up at the top, take this whole piece up at the top, and I'm going to take away this piece that goes from here to here, which is 6. Okay, so take a look. If I take away this 6 from this 14, I will figure out what this is. So all I have to do is 14 minus 6, and I do believe that is what, 8? I don't want to tell you wrong. I'm going to double check. Yes, 8. Okay, now I know my picture doesn't necessarily look like that one is bigger than the other ones, but it's okay. My picture doesn't have to match in length. Okay, it doesn't have to match in length. I know everything seems to appears to be the same, but that's okay. So J to K is 2. K to N. Okay, here we go. From K to N, it's 2 plus 2 plus 8. So I'm going to do 8 plus 2 is 10, plus 2 is 12. Okay, from M to J, it's 2 plus 2 plus 2. Oh, we did that one already, 6. There we go. And from N to L is 2 plus 8, 10. There we go. All right. There are things in geometry called postulates. These are just rules that we are expected to believe without any proof. This is what a point looks like. This is what a line looks like, stuff like that. Theorems, however, are rules that must be proven. These are rules that we must prove. And so our first postulate, which is a rule really that we just this is what it is because it makes sense when we look at the picture, is called the segment addition postulate. This postulate says if B is between A and C, that's my picture right here, then AB plus BC is equal to AC. So let me go ahead and use color because I really believe that it's easier for you to see this. So AB plus BC equals, and let me change this to orange because yellow and the pink kind of make an orange, is equal to the same thing. Can you kind of see that yellow and that pink going into that orange and they create it together? That's exactly what this theorem says. It also says that if you know that, oops, let me change the color. There we go. If you know that AB plus BC is equal to AC, then that means that this picture must be true. Okay, so then that means that you have this picture. The segment addition postulate can be generalized into 3 or more segments on a line. Take a look at this one. We do have the whole one right here, and we can go ahead and say that PQ plus QR, and I need one more color. Let's go blue, I guess, plus RS is going to give us this. So we could go ahead and add more segments. So right here we could say PQ plus QR plus RS is going to give us PS. So basically what I can do with my color is I can take this formula and I can put it to any segment that I give you, and I can go ahead and change the letters. Okay, so if I just remember it's the yellow part plus the pink part equals the orange part, or in this last one, the yellow plus the pink plus the blue equals the orange, then I can do this geometry. Let's go ahead and practice. So suppose M is between L and N. Let's go ahead and draw that. There we go. M is between L and N. Before we move on, I can already go back and I can say this part plus this part is going to equal, let me bring back my orange, the whole thing, right? That's what that postulate, that rule on the last slide said. Now let's go ahead and add in our numbers. If LM is 7y plus 9, LM, well, LM is the yellow one. There we go. And MN, that's the pink one, is 3y plus 4. And then LN is 143. Solve for y, then find the lengths of LM and MN. Take a look at this, ladies and gentlemen. If I use the color, all I have to do is go back and say the yellow plus the pink equals the orange. That's it. The yellow plus the pink equals the orange, and I have done the segment addition postulate. Let's go ahead and plug in our stuff. I didn't need so much orange, but there we go. All I have to do, ladies and gentlemen, from here is I have to go ahead and solve this equation, okay? So remember, it's always a good idea to draw your line through the equal sign. You're going to look for your distributing. There are no parentheses, so let's go ahead and combine our like terms. Over here on the left side, there are 1, 2, 3, 4 terms, so there's probably like terms. Over here on the right side, there's only one term, so there are no like terms to combine. So let's look over here on the left side and ask ourselves which ones are like terms. Well, let's start with 7y and 3y. I can add them together to say 10y. And I can add them because technically, this one right here, the 3y, we should have circled the plus in front of it, okay? Then take a look, there's a 9 and a 4 left. You can actually combine them as well. And 9, oops, 9 plus 4 is 13. Ah, sorry guys, I'm using this calculator that I don't know how to use. Yes, 13. Since I did not say negative 13, I'm going to go ahead and say plus. The equal stays there. There we go. Now we're working on the side where the y is. So I'm going to make the y black this time. And I'm going to go ahead and I'm going to undo my addition or subtraction by doing the inverse. I see add, so I'm going to go ahead and subtract 13. Subtract 13. Bring down that 10y. 143 minus 13 is 130. I'm still got to get that y by itself, and I'm at step 5, which means I have to undo my addition or subtraction, which means I have to get rid of that multiplication that's hiding. Divide by 10, divide by 10. I'm going to bring it over here. Y equals 13. There's one of my answers. Now this question also is going to ask me to find LM. So all I have to do is go back and right here, and I'm going to say 7 times 13 plus 9. That's what I'm going to go ahead and put in my calculator. 7 times 13 plus 9. 100. And then it asked me to find MN. I'm going to go to my picture, MN right here. I'm going to say 3 times 13 plus 4. 3 times 13 plus 4, which is 43. To know that you are correct, this plus this better equal that, right? Because the yellow plus the pink equals the orange. 100 plus 43, yep, 143, we're correct. All right, let's take a look at example 4, and I do believe this is probably your last one. Yes, it is. If Ln is, find Lm if L is between N and M. Let's draw our picture. That means there's 3 points on this. L is between N and M. There we go. I can already know I'm probably going to do this plus this equals this. There we go. Let's see. And Ln is 6x minus 7, or sorry, 6x minus 5. Lm is the pink part, 2x plus 3. And my orange part, Nm, 3x plus 13. Whew, it's okay, we can do it. Use your color. Go back to the basics. This is like, I taught my first grader this one year. He's in the 3rd grade now, but I used the color and I taught him how to do this. Now, he could only do it with numbers, right? X plus 20 equals 50, and he could tell me what X was at the time, but he got the concept that add the yellow plus the pink in it or equals the orange. Guys, if you don't have this color, you can make the color, the three colors of your choices, but whatever color you choose where my yellow is, that's where your color is going to go. Where I have the pink, you're going to put your color, and where I have the orange is going to equal your color. So the colors are universal. Sometimes when you see them plugged in, you'll see them plugged in like so. Because remember when we substitute in algebra, we like to substitute using parentheses, right? Now, are these parentheses telling us to do distributing? No, no, they are not, because if you truly look at them, there's no number in front of any of these parentheses. So there's no distributing to do. So if you don't put the parentheses, it's really okay. So I'm going to go ahead and go back. Uh-oh, not like that. There we go. I was going to go try to be cute and go back and get rid of the parentheses because we really don't need them. There we go. Okay, now that bothers me. There we go. There we go. Okay, let's go ahead and combine our like terms. So remember, you're looking at each side and you want to count how many terms there are. So the left side has 1, 2, 3, 4. There are like terms on that side. The right side has 1, 2. More than likely, they are not like terms. And take a look at them. The 3 has an X. The 13 does not. I don't have to do like terms on the right side. Only on this side. Which ones are like terms? Well, 6X and 2X. And I'm going to go ahead and get that plus sign because I'm going to add them together for 8x. Then I have the -5 and the +3. So I'm going to do -5 plus 3, that's -2. Okay, now I need to get my variables to one side. I need to get my variable to one side. I'm going to go ahead and change my color really quick to pink to highlight that variable. I need to choose one of them to move to the other side. I'm going to go ahead and I'm going to subtract the 3x from both sides. Okay, this is going to allow me to keep my x positive, and it does give me 5x. I'm going to bring down the -2, and it's going to equal 13. All right, I'm focusing on this side where my x is, where my letter is, because that's my variable. And I need to say to myself, do I see addition or subtraction? And let's do the opposite. So I see subtraction. I'm going to go ahead and add 2. And what I do to one side, I must do to the other. Bring down my 5x. 13 plus 2 is 15. I've got to get rid of that 5. Remember, there's multiplication in there. So the last step is to get rid of the multiplication by doing the inverse, which is divide. And that would be 3. Let me go back and read to see if they wanted me to, what they wanted me to find. They wanted me to find LM. They wanted me to find LM. I'm going to go ahead and highlight that in my light green. Find LM. Well, LM is really the pink part. Why am I highlighting it in green? Let me grab my pink back. All they want me to do is to find this part right here. This part right here is the 2x plus 3. So LM is 2x plus 3. So what I'm going to do is I'm going to say 2 times 3, that's 6, plus 3, 9. Good luck on your assignment, guys.